Hello friends, welcome once again. In this video we are discussing question 6 to 10 and for remaining question you can refer again next video. Please subscribe to our channel if you still not subscribed. So let us start. Question number 6 है 4 point charges QA 2 microcoulomb, QB minus 5 microcoulomb, QC is equals to 2 microcoulomb, QD is equals to minus 5 microcoulomb are located corner of square ABCD of side 10 centimeter. What is the force of charges of 1 microcoulomb placed at the center of the square? So there are four charges plus 2 microcoulomb minus 5 microcoulomb plus 2 microcoulomb minus 5 microcoulomb are placed 10 centimeter apart each other. So it is given at a square corner. So AB the side of square, BC side of square all are equal, so 10 centimeter. Diagonals AC is equals to BD because both the diagonal of square are. So calculating diagonal by using Pythagoras using 10 centimeter 10 centimeter, so we get square of 10 centimeter plus 10 centimeter square, so we get 10 under root 2. So that is the distance of diagonal. Similarly, OA is equals to OC, the distance from center to diagonal. So charge of amount 1 mu is placed at the O point. So force on charge between normal of center magnitude but opposite in direction relative to they will be cancel each other. So charge due to minus 5 microcoulomb will be in this and minus 5 microcoulomb, both will be repulsive force at the center, and similarly due to plus 2 microcoulomb and plus 2 microcoulomb the force will be repulsive in nature. So net charge will be at the center is 0, and you can say net force at 1 microcoulomb charge at center is 0 because forces due to both the charges are cancelling each other. Next question, 7th number. An electrostatic field line is continuous curve, that is field line cannot have sudden break. Why? And explain two field lines never cross each other at any point. And electrostatic field line continuous curve because charge experience continuous force, hence when they are traced in an electric field or electrostatic field, the field line cannot have sudden break because charge moving continuously and does not jump from one point to another point. So basic reason behind this is that they are experiencing a continuous force, and when we are drawing the particular line, it will give us a continuous line. If two fields line across each other at a point, then electric field intensity will show two direction at a point, and it is never possible having two direction at a single point, means we cannot draw two tangent at a single point, hence two field lines never cross each other. So if we are let's electric field line 1, electric field line 2, and if we are there crossing each other, means there is tangent 1 and there is another tangent 2. It is not possible having two tangent at a single point. Question 8. 2 point charges QA QB are located 20 centimeter above. What is the electric field at the midpoint O of the line AB joining the two charges? If negative test charge of magnitude is placed at this point, what is the force exerted by the test charge? So 2 point charges are given, QA QC located at 20 centimeter apart in vacuum. What is the field line joining charges if the negative charge? So answer is given by situation is represented A point plus 3 microcoulomb, B point minus 3 microcoulomb, distance between A and B is 20 centimeter. So OA is equals to OB is equals to 10 centimeter. Net electric field at point O is equals to E. So electric field at point O is caused by 0.3 3 microcoulomb charge. So here the net electric field is created by 3 microcoulomb charge. So it can be calculated as E1 is equals to because formula is 3 into 10 to the power minus 6 upon 4 pi epsilon naught upon OA, that is distance between the 2 points A and O. So we are calculating due to the plus 3 coulomb charges, plus 3 microcoulomb charges. So it is given in Newton coulomb. So it will be along OB direction where epsilon naught is permitted, putting the values of 1 upon 4 pi epsilon 9 into 10 to the power 9. Magnitude of similarly E2 will be given by 3 into 10 to the power minus 6 4 epsilon naught microcoulombs. So total electric field will be E1 plus E2. So putting the values, since the values of E1 and E2 are same, the magnitude will be twice of the itself. So we get ultimately 5.4 into 10 to the power minus plus 6 Newton coulomb along line OB. Therefore, electric field at midpoint O is 5.4 into 10 to the power minus 6 Newton per coulomb along OB. The test charge of amount 1.5 is placed at midpoint, means we are putting at this is the point A, this is point B, and we are putting a charge another 1.5 into 10 to the power minus 9 at the midpoint of the both charges. So force experienced by test charge is given by F is equals to Q into E, because electric charge force per unit area of E is equals to F divided by E Q. So we'll get 1.5 into 10 to the power minus 9 into 5.4 into 10 to the power 6. So we'll get 8.1 into 10 to the power minus Newton. So the force is directed along line OB. This is because the negative test charge is repelled by charge placed at point B but attracted towards point E. So therefore force experienced by test charge is 8.1 into 10 to the power minus 3 Newton along line OA. Question 9. A system has two charges QA, QB located at point A and B respectively, means they are coordinates in 2D, 3D, 0, 0, minus 15, 0, 0 and plus 15 respectively. What are the total charge and electric dipole moment of the system? So representing this system in 3D system, here x axis, y axis, and this is your z axis. So taking negative other side and positive this side, so 0, 0 minus 15, 0, 0 plus 15. So the distance between 2 points will be ultimately 30 apart. So A charge given by B charge given, total charge of the system plus QA plus QB, that is will be 30. So both charges are opposite in nature, so 0 net charge. So distance between two charges is 0.3 plus 15 plus 15, 30 centimeter divided by 100, we get 0.3 meter. So electric dipole moment is given by P is equals to Q into D, so QB into D. So multiplying we get 7.5 into 10 to the power 8 coulomb meter along positive Z axis. Therefore electric dipole system is 7.5 into 10 to the power minus 8 coulomb meter along positive direction. Next question. An electric dipole with dipole moment 4 into 10 to the power 9 coulomb meter is aligned at 30 degree with the direction of uniform electric field of magnitude 5 into 10 to the power 10 Newton per coulomb. Calculate magnitude of torque along the dipole. Electric dipole moment given, a magnitude angle given 30 degree, electric field given 5 Newton per power 4, torque acting is given by PE sin theta Putting the values, value of P, value of E, and value of theta, we get 10 to the power minus 4 Newton meter. Therefore, magnitude of torque acting on dipole is 10 to the power minus 4 Newton meter. Thank you friends for watching video. Please subscribe to our channel if you still not subscribed.